Hello everyone, welcome back to this tutorial series for creating the World One with Grasshopper. Last time we prepared ourselves the setting out for us to make actual geometries, meaning the column for the first block, namely. So that's what we're going to focus on in this part of the video. And there is actually something that I missed in the previous video, and that is related to the ordering of this data that we prepare for ourselves. Because now we prepared three trees, three branches, each with their own elements that resides to their own block. But as you will see, that actually creates a little bit of inconvenience for us, which I will show you actually right now. So to start for the lower block, what I'm going to do is I'm going to create a panel. I'm going to type in 0 because I know 0 is the starting block, and I can actually just call this block select, because we probably can use this whole script for the next one and so on and so forth, but we'll see. So now that I have that, I can use tree branch, which I will select the whole branch. And for that, I obviously need to copy these two, connect them again, and make their wire hidden. I'm not going to be mainly focusing on the secondary arc. So the trees goes into the T, the path, which is 0, goes into that. So if I hide everything, actually I can also select for this one. You'll see that we've only got the first block level selected, which is good. Now the next part is, now what we've done, we've actually now selected the first branch, and that's a single branch which will list all the items in one list. So if I were to put in a param viewer, you will get one tree with 18 items. Well, you can see there are only 6 lines. That's because some of these lines, the straight section, are not joined yet. But that's fine. We can join them with a join curve command component. That's okay. That's still doable. But what comes next is, how do you know which one is number 1? Which one to choose from? Because we don't need to work on all 3 or 6 lines at the same time, because the what we want to do is actually similar to what we've done before for the big ones, which is basically take a point here, okay, and draw X amount of lines that correspond to how many columns you want. So if I draw 6 lines here, then I want these 6 lines to intersect. But how do I select that line or that line? So how do I make sure that this is always number 1 or that's always number 2? If you want, you can easily use a list item and then just manually select them one by one. But why do we resort to manual work? Why not do it more smartly and, well, parametrically? So that's what I mean by, before we go on with this, there's actually something we still need to do with our preparation there, and that goes on for every one of these. So the thing what I propose to do is sort them in a way that we can easily select it from this part on, using a bridge command, and then can easily distinguish which one is the outer one, which one's the inner one. So we go back here, we know that this is the inner curves, okay, as noted by this one. Although I do see in tree branch 0 has 9 items. That's because all these curves are unjoined, so it may be a high time that we join them, but maybe we can join them all the way in the beginning. Well, certainly not this one, because that one is, we need that exploded so that we can filter out. So I think we do have to join them at the end, so that's fine. So what I'm going to do is, if you don't know already, if you hold down Control Shift, you can drag a whole input and replace it somewhere, and then we just need to connect that one back. So now we should have 3 items for the first branch, which is 3 lines, so that's fine. I'm gonna actually do the same for the outer lines. I think that comes from this one. So I'm gonna join that one also, and I'm gonna replace that one also here. Well, actually, no, don't replace it yet. Okay, so now what I'm gonna do is I'm gonna actually show you in a let's do just point. No, let's do curve evaluate, so I can visualize that easily for you. I'm gonna reparameter. These are just temporary. You don't need to put these in. I just put these in order to show you, so you don't have to copy me, but you are obviously allowed to if you want. But that won't do you anything. So it's up to you. So now if I point it a point list, I might need a bigger point. Way bigger perhaps. Okay, that's fine. And I'm going to do the same for this one. Okay, so already you can see a discrepancy. See how the outer curve, this one, maybe I should just color it. There we go. See how this one, this is the outer curve, okay? And just call it the other one too, make it easier for me to explain. See how the magenta curve begins with here, as you can see by the 0. And the next one's going to be here, and the 2 is here. And then the inner curves has the 1 and the 0 switched, which is not good for us. So we can already see that by ordering these is not enough. So we need to pre-order this in order to make sure that they're aligned. So the first thing we're going to do is we're going to align the inner curve, which is this one. And the way we're going to do that, we're going to actually align them by points. Which, actually we can use this. Well, these are these are the points that we can use. We can do a point closest, this one. Point closest to point. And what we want to do here is we want to say the point to search from is going to be our outer curve, which is the magenta ones. The point to search for, it's going to be the blue ones. And what you will see from the output index, the I here, you should see the ordering that they should be, which in this case, the blue one should be at the 0 position. The 2 doesn't change, and it seems for our second one is like, oh, okay, let's clear that screen. For the second one is actually flipped because we want to see a 0, 0, not 0, 1. 0, 1 means this 0 is actually tied to this curve, which is obviously not true. And for the last one, well, there's only one curve, so there's always going to be 1 items. So with this, what we can do is we can reorder our inner curve, if you select that, using a list item that uses the index that we simply reordered. And now if I copy this point, just so I can do a point list from that list, I'm going to hide all of these and witness and see how once I plug in the P to the P here, you will see 0, 0, 1, 1, and 2, 2. See? And now we can be sure, 100% sure, all our curves are going to be ordered the exact same, the exact way, the exact order that we expect them to. So now I can delete that. I don't need that anymore. Which means maybe I should create some more space here. Let's drag these a bit. Can I drag these even more? Not really, but that's fine. I only need to drag this a bit more like here, and that one here. Drag a bit down there and like that. Okay. So now we don't need that. We only look at this one and this one. So these are the 2 outermost output that we're going to be using. And the next part is, like I said, I have 0 here. This is 0 curve. All I want to do is create groups of 2. Right? Because when I create a groups of 2, I can, in the end, in here, I can easily say, I want to select curve 1, and curve 1 will then be only the outer curve. And I say group, the second curve is going to be always the inner curve, which should make it more predictable for us and easier for us to select the data that we actually want to select. So the question becomes, how do you want to group this, and how do you even group these two? Well, the answer is pretty simple. You just plug in the joint curve into the D1, and we plug in the sorted curve into D2, and let's open up a param viewer so that you can see what's going on while we're doing this. So the tree structure is fine. It's exactly what we expected, but we still haven't really grouped them together. So the final trick is actually to graph all of this. And what that would give us is more than 6 for now, more than 6 branches, but that's okay. We are not done yet with our processing. But see what we are able to do if we do a list item, no, a tree branch. If we select the tree branch, let's say this one. Let's simplify this and then just plug in a number sliders. Or actually, the tree branch doesn't work this way because we have a different path. Okay, that's not really working well for us in this sense. Okay, let's do it like this then. Let's do it the very manual way, just to show you what we've done. So 0, 0, actually let's simplify this one also so that you can, 0, 0 should be this one, this branch, and there are 2 items. And see how we're able to easily select groups of 2 with this method. So now I've selected that group. So if I do, let's say 0, 2, what I expect is, remember that this is 1, this is 0, this is 1, this is 2. So I expect to have this one to be turned green, to be selected. And there we go. So in the same manner, if we were to select this group, it's going to be, I think, 1, 1. Because I remember 0 was the one on the left, so 1, 1 should be on the right. There we go. And the good thing about this is that if you were to do a list item, on the first curve, it's always going to be the outer curve. The same goes for if I do 1, 1, 0, 0, sorry. I expect to have that curve selected. And there we go. So with this, our data becomes super predictable for us to select. The only thing now we need to do is to restructure our data tree in order to get the same 3 branch as this one, like this. So what I want to do is, since I don't want to lose my data as in this one, what I can do is I can group, literally group all our points into groups. Groups is well, it's what the name says. It's a group of geometry. As you can see here, if you put in a panel, it's a group of 2 objects, and those 2 objects are our curves. And now I can actually flatten this, and I'm gonna repartition this list according to a specific tree. Hey, what does that look like? So we're gonna restructure this into that type of tree structure. And one way we can do that is, because we know the first 3 item belongs to the first tree, meaning tree at number 0. So what we can do is we can create a partition list. We've already done here with a specific size, and that size we can actually derive from the number of columns, so that we have 3 items. But what we want is actually the top one should be 3, because that one has 3 items in it, meaning 3 groups. then 2, then 1. So what we can do, you can actually specify a starting item here on the S, but now it goes like 3, 4, 5. Well, then the stepping angles can just be -1. Then it will just be like 3 minus 2 minus 1 is 2, and then that 2 minus 1 is 1. So this can be our set, which should give us this, and ta-da! Same tree structure. Well, after simplifying. There we go. And now this can go into a secondary arc, which says it's not is red because, well, groups are not curves, obviously. So we need to provide a different type here and just do generic. Or actually, you can also do geo, which is geometry. I think both works. Doesn't really matter which one you choose. They both work. So if you want to go for geometry, if it makes more sense, then we go for geometry. I just need to copy the name here. I can delete all that because I don't need that anymore. I do need to replace its connection from the old one to this one. And don't forget to select all of the new components and add them to the group because they were not added to the group. They're inside the group outline, but they're not added. You can check that by if you move the group slightly and you notice that one component is not moving, then that component does not belong to the group yet. That one is red because still a group is not a curve. So we can do this and hidden that line, replace that, and there we go. We've changed the ordering, but now we have groups here, meaning, oh, you can actually see it here. And in order to get our curves back, we just need to ungroup it like that. Now, the good thing is, if I were to do this, a list item, see how if I plug this in, I will only be selecting the 3 outer curves, like so, which makes it a lot easier for us to manipulate our data and then ignore the second inner curve for now, because we just need to define the 6 or the however amount of columns you want. This one, yeah, that one can stay. Actually, that one can stay open too. But if you want the other one, you just click a plus here, and then you will get both curves. So that means that this one can stay. And now what we want to do is we want to do the same trick as what we've done for the main column. Like that. Like we want the same thing as this. So you could come here and copy all this, but I think you have more time figuring out why you copy that, and I think it's just best to do this again. And well, practice makes perfect. If you understand this, if you understand the previous one, remaking this should not be that hard. So let's do our best. Okay, first thing first, what do we need? We need a point that sits around here that we can use it to project our vectors, because that's how we did it here. We basically need these 2 points so that we can create a vector and then we can rotate that vector, right? That's the concept of it. That's the idea. So here's what we're gonna do. We're gonna do curvature. We're gonna use the same one. Okay, let's keep that away in case we choose the wrong curve. That will be disastrous. We parameterize it so that we can say 0.1 is 0.5 is going to be the middle of that curve. So now that we have that, we can say deconstructs a arc, or you can say area, but we just want the middle point here. Deconstruct that arc, so we have the middle point, and I believe also that axis, which is fine. Okay. Let's see, what are these? Okay, that's fine. So now we can do a 2-point vector that goes from the base to that. And if you want to visualize it, you can use an SDL line that comes from this with that as direction and that as the length. or we can just do a vector display. Actually, maybe that's a lot better for now. Okay, we can actually delete that one now. Hold on a minute. I actually want it to be flipped the other way around, so let's flip our points like that, and the anchor is going to be that one. Okay, now that we have our vector visualized, what we can do now is create a slider and say a minimum of 3 columns to a maximum of 10, perhaps. And we're going to call the number of columns. And I think the original tower has 6. So we're going to put this at 6, like that. And we also need to define a domain, a maximum error domain. Actually, we can actually take that domain from here. Not sure if we should do that for now, but okay, let's continue on with creating the 6 vectors that we need. So we're gonna do a vector rotate. This one. We are going to be rotating this vector around a z axis. So I'm going to connect that here and immediately internalize it so that it sits within this variable, so that I don't have an extra variable that really doesn't do a lot. Right click on the A to convert it to degrees. And now we have to specify the 6 degrees that we want to rotate to. And now if you look at the previous one, what we've done here, we've defined a max angle, okay, and we can basically actually just copy this one and this one. So I'm gonna Control C. I mean, this part is easier to copy instead of building it. I mean, you can build it yourself, it's just totally fine. What's this? Number of steps. Oh, I have to replace it with this one, so that we have 6 values. So we can connect that here, and there's our 6 values. And you can maximize this however you want. Be sure to not maximize it too much. If you go outside the actual range of a geometry, which I do think, well, here's the thing. You have basically 2 choices. First being, do you want to be able to control where you want your max angle? For example, if you want all the columns to be here only and there, then you can just control this one, right? But if you want it to be controlled and only control the amount, then the next thing what I suggest we can do, or what you can do, is define the max angle as an angle of your circle, which I believe is 60 degrees or something along that line. But we can check that if you do a degrees, because the A here is in radians. So if you convert that to degrees, oh, this is actually the circle, that's why it's in degrees. This is not going to help us because it's coming from this one. But we actually want that curve right there, which I do think it's 60. So if I quickly explode this, and let me just select it by using this. This is just to show you. This is not exactly what we're going to be doing. I'm just going to show you, if that's the route you want to take, that this is one of the way you can do. So notice how I have that one selected, and I'm going to deconstruct this arc. I know it's an arc, and I'm going to do this. 56.9999999. So that which means that this arc right here has a maximum domain of 60. So if you want all your columns to be only there, then you can have it controlled. Then it will suddenly be like this. But that will mean that you will never have a column that sits on this straight section, which is why I am basically ignoring the maximum domain that it can hold, because I want a column to be on the straight section. And if you look at one of these pictures, there is at least one column that sits on this straight section, and that's why we are doing it the way, like controlling these two manually rather than have the max angle be controlled or derived. But you always have the option to have it derived, so that's up to you. Nonetheless, which one you choose, we can just continue on because we just need 6 vectors. Okay, so we have our 6 vectors, and the next thing we want to do is rotate our 6 vectors again according to a step angle. And if you don't know how we've done that, we've actually created a step angle here. We created 2 numbers, so maybe you can just copy this one instead, which will make it easier for us. Or maybe you shouldn't be too lazy and just do it like, like a number slider. So let's do that instead then. 1 degree spec minimum to 6. I'm not even sure how much we need. Step angle. And we need 2 values. I'm gonna create here to visualize for us. There is a number. Gonna copy that and another number. This is a minus x divided by 2. I'm gonna copy. Oh, this is a minus x divided by 2. I'm going to copy that and I'm going to paste that in here, except that I'm going to get rid of the minus. There we go. And now we want to rotate each of our vectors again. I can just copy this one actually. I want to rotate each vector, so what I'm going to do is I need to graph this actually, like that. So how many do I have? 6. 18 total here times 2, that should be 36, and there we go. We have 36. Although I'm not quite sure if this is enough. I think if I apply this here, it's not gonna be the what we expect anyway. So here's what we're gonna do. We need a duplicate data, so that we can duplicate the amount of points that we have. We're gonna duplicate that point. We might have to set this to false, because last time we also need to set this to false. The number of duplicates we want, how many data do we have here? 3. Well, we need to duplicate that 6 times because we have 6 columns. This one should go in that one. I'm expecting 36. 18 times 2, x times 2, because we have 2 vectors that makes up a single column. So now if I do this, the data structure is wrong. Aha. If I simplify this and do a trim tree, or actually simplify the t instead, so that we get, okay, 1 degree is obviously way too small for our columns. Let's do 3.3, 3.5, something that looks okay. Okay, so now that we have this, what we can do, we can actually do an SDL line that's that comes from these, with these vectors as direction. And as for the length, well, it should be a little bit longer because this is a straight section, and so these curves are actually not long enough to touch that line. So what I propose is, do I even have a length here? I think I have a length somewhere. Oh, this one, which is, I think it's 15. No, oh, 20. Okay. I might need to duplicate that also, seeing as all this is duplicated. Well, actually I don't, because I already have 3 trees there. I just need to disable that. Okay, that's where we go. What I want to do in order to make these connect, I want to do x plus comma x time 0, 1. So 10% longer than the actual length. And this is what we get. We might actually want to extend that even further down because actually, yeah, I think we might have to for the second level, but we'll see how this goes for now. So the next step is we need to do a curve-to-curve intersection, which is this one. Intersection physical curve-to-curve. And the one we want to intersect is actually our initial curve, which is this one, which has a data structure of 3 trees, so that's fine. We're going to put this to A. The data structure is still okay here, so we're going to have to put this to B. We're going to hide that. We're going to hide this one too. And now we can do shatter. Oops, no, shatter. And we are going to shatter that curve. The outer curve. This curve. And we're going to shatter it based on the t parameter. A tree needs to be fixed also. There's three branches. This one has way more. So obviously we need to trim the tree back down. Actually, let's not do that. Let's copy this one instead. We want to simplify the t here. And what data do we have? 3 branches. Good. So now we can do a calling pattern that uses a true-false value. Let's start with true and false like this. If you don't know this way, this part is actually we've done it the exact same thing here. So if you want to have more explanation, I think I've explained it a little bit better in this video that explain this one. I think it's part 2 perhaps, or part 3. But I can actually explain it briefly also. What it does is we have shattered it one by one. And with the calling pattern is we want to call it true, false, because we know after one column there's going to be space, and then column, and then there's going to be space. So with this, we hope that we are actually selecting the middle part. And we are, it so happened that we are actually selecting the part that we don't want. So we need to either flip true and the false here, or you can right click on the P and you say invert. And there we go. We have our 6 outlines, and we just need to do the same for our inner curve. And I'm actually crossing my finger now because I haven't analyzed the curve parameter of the second curve, so this is going to be a mystery. I hope this will turn out, so we'll see. Exactly. Yep. This is kind of what I mentioned that I don't know how to turn out, because if I do quickly a curve domain, and I analyze the first curve, or the first curves, because now I'm selecting more, you can see the domain goes from 0 to 20.6. But if I do that for the second curve, and you'll see the domain is from 0 to 30. And why is that? Well, the difference in domain actually comes from the way we combine the data. The first domain that comes from this one, and it just moves all around here, got joined, and then combined. Whilst the inner one comes from a joined overall curve, and then cut using a shatter, so that we remove the tips, the three main wings, let's say, and then we combined it. So if these curves were coming exact from that one, it might have been the same, but because we've joined them, the curve domain could have been messed up, and in our case it did. So that's not good for us. So what we can do is we can actually reuse this part and do this part again. But since our curve are not touching it, what we're gonna do, we're gonna increase the overall length to actually I think we can just go x times 2. That'll be long enough. I mean, the length of that is actually depending on how far is your balcony depth. So we can actually include the balcony depth in it, then we can be sure that's always in there. Or maybe twice is too much, so maybe we'll just do 50%. So x times 50%, like that. And then we can do this, and the a actually comes from the secondary curve, which is that one. And we need to do the same here, so I'm going to connect this one to the t and hide this one. And this one will work. There is actually another method which you can do this. It's less reliant on this one. So you can leave this at the 10% that it was, and it'll always be correct. Let me delete that one. And that is actually point closest to curve. But there is a small, I think there's a small deviation if you do this, but let's leave both on and you can judge yourself, or you can see which one do you like most. The point that we want to start is obviously those, and the curve is our inner curve. Obviously, we need to fix some data structure here. Let's see, we need to fix that data structure. We need to copy this one and trim the tree so that we have 3 branches that goes into here. What do you know? Actually, they're quite close to the other one. Well, yeah, they're super close, except for this part. Because it's straight, and because this part here is straight, let me open up this one instead. Because that part is straight, well, the closest point is obviously going to be straight down there. But remember that we've used a sort of angle from that part, which sort of destroys it. I mean, do you want the column to be slightly off, slightly going from a center radius, or do you just prefer it to be the closest point? Which both technique I would say works fine. And actually looking at this personally, I might go for this one instead, because now that I've mentioned, I think this one, this one is actually quite how do you say it? They're quite rectangular. They don't really follow the step angle. We might actually go for this one. Actually, could be. Well, we just need to choose one, and since I have this already here, I'm just going to choose for that one. But both, like I said, both methods works, and it really doesn't matter which one you choose. The only thing that matters is the end columns might be a little bit different, and I guess that's the only difference. Okay, so now that we have this, we can actually start combining these into actual columns. But first, we need to identify which one is number 1, which one is number 2. So if I do a list item just in case here, it selects the first one there. Okay, that's fine. And if I do this, it selects the other one, which is also fine. So if I do a merge actually, and graph the output, or the input, and then I do a connect. Oh, I do need to flip one of the curves first because, okay, let's not flip it first, and I'll show you why I need to flip this first. This is what you get. Because both curves are going to the same direction, and you need to flip one of the curve and set the G to position in order to get the curve outlines, the columns outline that we actually wanted. Imagine if you hadn't flipped it, it would be like this. If that's the column that you want, then by all means go ahead. This kind of looks funny, doesn't it? Wait, let me let me actually bring back the other method. Point closest to curve. Maybe that one does look a lot better, to be honest. Point closest to curve. Yeah. So these are the points, and the curve closest is the secondary curve. And I'm just going to replace a T on this one. Do you notice anything? Slightly. Well, only that one is changed. And I do have to say, this one looks more natural. This one looks a bit skewered. They do follow the step angle, but it looks a bit skewered, so ooh, tough decision. Okay, let's go for that one. Let's just delete that one, delete this one, and let's make a bit more space for our new member, like that. And there we go. Now we have that set up. This is a bit skinny, but that should be fine. Let's see how it works if I increase this. It works fine. If I increase the number of columns, works fine. If I increase the thickness of the columns, works super fine. Was it 3 or 3.5? I think 3.5, and this one was 6. And I don't remember what this was, but yeah, 70, I think, something like that. Okay. Okay, so now we have all the outlines of the columns ready and done. The last thing is we can do a boundary surface on these. The same goes for our main columns, like that. Actually, now we can extrude this all up. Let's put this to render mode. And where is our height? This is our floor height, so we need that. And the next thing we need is the floor heights. So let's create those. Not floor, the amount of floors. So let's create those. We'll just start with a minimum of 10 floors up to about 60 floors, I think. So we're just gonna call these block 0 or block 1. Yeah, okay, let's call it block 1 floors. And then we're gonna copy that and then call this one block 2. We're not gonna create a one for block 3 because block 3, the last block, is actually what's left from the maximum. Or I guess what we can do is create block 3, and then the maximum floor will be determined by that, and the height will also be determined by the total floors times the floor height. That could work. Then you can truly control your tower height however you want. But since we are going to be sticking for now to the original as close as we can, we're going to leave it at that. I think the original had like about 42 floors. But that's like 43 floors for the initial block, and then the second one has like 42, and the rest is all the top floor. So we're gonna let's create a copy from that. Create another copy. We're gonna call this, wait, what happened here? Okay, obviously something went wrong, so let me try that again. I'm gonna copy this one, copy this twice, hold Alt, toggle Alt once, toggle Alt once, toggle Alt once, and toggle Alt once. And for floor 3, what we're gonna do is we're gonna make a formula for now that say the formula is basically the maximum, which is gonna be that one, which is gonna call x minus y plus z, and y plus z is actually floor 1 and 2 combined. We just need to add that one. So this is x is the maximum, and these two are added together, which, oh, I don't need to create a copy, which give us block 3 floors. 32, that's the number. We need to add this to our parameters, and I need floor 1 and floor height. I'm gonna copy those all the way here. I'm gonna Control Shift V to paste in place, or paste in the middle actually. And now we can do some extrusion. So in order to get the maximum height for the extrusion for our main columns, we can do a multiplication of the amount of floors. Let's do like the amount of floors times the height, and that should give you 162.5 as a overall height. Let's see. Okay, let's just call this height. I'm gonna connect it to the z-axis because we will be moving, extruding all of these. Let me merge these two together for now. Let's do that so that I can merge them all at once. Or should I? Probably not, but we'll see. We're gonna extrude this up. Actually, let's move this way closer so that I know what I'm extruding. This one gets extruded, and wait, I can get out. How many items do I have? 27 extrusion. Okay, well, there's our columns, all of it. And now we actually want our floor also. So in order to get our floor, what we need to do is actually we need to work on something else. We need to get the outline of our floors. I think we might need to get this. Oh no, actually we need the main outline. We got the main outline from this. Is that an output that we can use? No, not really. But we can create it. Yeah, we can create that. So we can actually, let's move this slightly off. Move this slightly here. We're gonna copy this one and that one. Oh, let's disable that, and we're gonna come in here and then we say paste in place these two, hidden. Actually I have to replace the connection from here to here so that all comes from that. Okay, so now I can say join. And I can do the same thing, except that I don't need to select the tree. I only select the first item. I obviously need to flatten this part. And now I also need to have the offset to the inside. There we go. Now we have that one. And now what we can do is, well, with this one we have the core, so I can actually use this one already for our core, because there's always a core inside. If you look at any picture, actually you will see there's a core. I mean, we're not building the floor interior. You You definitely can if you're up to the challenge, but for this tutorial, we're not building the interior. So let's do this one, and this one is now our core. Let's actually put a nice swatch color. Let's do preview. And we're gonna preview this to well, cores are usually what color? A little bit gray perhaps. I mean, not brown gray, like a light gray-ish, something like that. That should be our core. Yeah, so if we're going back to the floors, what we want to do is we want to have these two, the region joined. So if you want to do a region join, where is it? Region union. Actually, it's not a region union, it's a region difference. Here, intersection, region difference. So the main we want to subtract from is this one. This is the main region, and we want to subtract that one so that we can only have, actually let's disable this for now. So we can only have the outline of that. But the problem with this is it will then have a double surface with our column. So we need to also extract all our columns from this region difference. So what I'm going to do is actually flatten the B and then put in all our columns. I need curves, I don't need surfaces. So what I'm going to do is actually, I'm going to do it like this. So this one will go here, and the main columns will actually go into that one, and this one will be our surface, like that. So now I can actually use this one and plug it into that. And what you get is actually, let me disable this one. So this is what you will get. Where there's a column, there is a gap. And that to prevent, once we extrude this, so let's do that. That is to prevent the, this is actually not extrude, we need to extrude. That's to prevent double surfaces along the columns. But this is our floor, okay? So it's not our core where we have to extrude it all the way up. So we need to actually, oh, the floor height, where is it? This one? No, that's not the floor. I think we missed one more parameter, which is the floor depth. Do we have it? No, we don't have it. So let's create it. Floor depth. What's the floor depth on this one? Let's say a minimum of 10 centimeters by 1 meter. Is that a lot? Oh, 0.1, smaller than 1.0. And we're going to set this to 50 centimeters, and we're going to call this floor thickness, floor depth, floor thickness. There we go. So we're going to copy the same output that we use here, like that. And we're going to add this to the group. We're going to copy this one. Going to use it all the way here. V, no, that's not called V. This is a floor thickness, 0.5. That's fine. Actually, no, let's do it like this. There we go, 0.5 as our floor thickness. And then we want to extrude that. So we want to extrude it in the negative side. That's because when you're up to the roof, you don't want this to stick up. And now we need to define our floors. Where we have our floors. There's our floor. We have 43 floors, and if you actually look at any picture, so let's get rid of plan and just say pictures, you will see that the bottom two floors is actually, there's no bottom two floors. Do I have a nice picture that I can show you? Maybe perhaps here. Like if this is the tower base, you can see that there's missing like 2 floors. It's like an entry, it's like a lobby, you know, you don't have floor straight there. There's like double height lobby in there. So there's no floor in the first 2 levels. And that's what we're gonna do also. We're gonna do a skip of these floors. So we're gonna do series. Let's make a series of floors. And it will have, let's do it this one. It will skip 2 floors, okay? So then we'll say floors to skip. And we're just gonna pop that somewhere in between here. Like that, like so. We are actually going to multiplication. Whoop. Let's do a multiplication. In order to establish from what floor should we move this up, and I want to move this 2 floors times the floor height, which is this one. So it should start at 7.56. Actually, let's put this to meter right now, since we're now working on with that. Unit tolerance. Yeah, that's fine. And now it's meters. So it should start, our series should start at, let me create another panel, at 7.5, and it will have an increment of floor height. And the total number is actually the total number of floors minus 2. So I'm going to do a subtraction. I'm going to subtract the amount of floor by 2, should give me 41. And the minimum and the maximum height is now 158 with, I suspect, 162. Why is that? 41 values. Or should I not have one more value perhaps? Minus 1. Oh, let's right click on the C and do x minus 1. What do we get? Oh, I should actually do x plus 1. Now I'm getting even less floors, because 0 is not counted, that's why. Wait, I thought I did plus 1. There we go. 54, which matches that one. So that's fine. Do I need the panel? Probably not. I can move this one up here though. And this one will go to a move on the z-axis. Oh, what happened? So this is gonna be moved according to all our floors. Aha, okay. So what happens here is we are moving how many items? 42 items. We are having 42 vectors, z vectors that applies to 26. So we need to graph one of these in order to make sure that one of them will be applied to every one of the other list until the end of that list. So which one should we graph? It doesn't really matter which one you graph, but if you graph, let's say, the vector, what you get in the end in terms of data tree structure, you will get each tree is going to be one level. So that makes more sense for us. So that's what we're going to graph. And now if you enable back our columns, you will see that they don't match. And this is why we have that gap first before we extrude it. Which, if you're gonna bake this and render, this will prevent you to have double faces. And double faces in render is something you should really get rid of. And now you see the tops also very neatly. Let's give it a nice color because this color red is way too bright. Obviously, I'm not gonna give it a gray. What's this one? This is the floors. Let's create floors of. Oh wait, this is the column. The columns, huh? Well, the column can be any color. The floors can be different. Let's create a nice color like that. Let's create something like a brown copper-ish color. And for the floors, actually, I think the floors can be a bit, maybe a little bit blue-ish, like that blue. Oh, that blue's nice. Maybe a bit darker, something like that. No, actually, no. Something that can match the brown. All right, let's do a red. But let's do a very faint red, like that, like this, something like that. For now, I mean, it doesn't really matter. Okay. By now you have completed the first block of the World One. And coincidentally, if you remember from the start, the World One is actually part of 3 different towers. And the other 2 towers is actually, one is called Road Crest and the one is called Road View, I think. I think it's just like that one. If memory serves me right, I think the other one, the shortest of the 3 is, I think it's basically this one. Or not actually, I'm not sure. But we have created 1/3 of our tower. And in the next part, we are going to be focusing on the other 2 blocks, which should be fun, and it should be fast too, because we've set up this one. We just need to do some minor adjustment and we should be done. But first, let's give it a name for our column, and then we just call it this is 50. Just call it block 1. There we go. Okay. I hope you've been able to follow me thus far. If not, please leave a comment and I will try to help you out as best as I can. Until then, I'll see you in the next one.